Go ahead, Matthew.
Thanks, Nalima. It's my great pleasure to introduce our two speakers for today's ICICLE Symposium. I've been working with Laura Schmidt from UCSF and Amarnath Gupta from UC San Diego and the San Diego Supercomputer Facility on a project called NOURISH. NOURISH is a NSF Convergence Accelerator. Some of you who know me from ICICLE may realize that I've just changed my background screen to reflect that not only am I affiliated with NOURISH and the Smart Food Sheds platform, I'm sorry, not only am I affiliated with ICICLE and the Smart Food Sheds group within ICICLE, but I'm also affiliated with this NSF Convergence Accelerator. So NOURISH is a platform for alleviating food deserts, and the PI is Laura Schmidt. She's a professor of health policy in the School of Medicine at UCSF, and holds a joint appointment also with the Philip R. Lee Institute for Health Policy Studies and in the Department of Humanities and Social Sciences. Dr. Schmidt seeks to understand how changing lifestyles are contributing to rates of chronic disease across the globe and what we can do about it. Her work explores the growing pressures of globalizing economies and rising inequality, specifically with NOURISH related to food. So she's going to walk us through the social aspects of the NOURISH platform. And we're also joined by Dr. Amarnath Gupta, who's has his PhD in computer science from Jadavpur University in India. He's a research scientist at the San Diego Supercomputer Center of UC San Diego, and he directs the Advanced Query Processing Lab. Amarnath is also a co-PI on the National Data Platform. So we're going to hear from him about the technological how the NOURISH platform is being developed. Full disclosure, I am also a co-PI on the NOURISH platform. And those of you in ICICLE know I'm part of ICICLE and the Integrated Knowledge and Learning Environment platform that we're building for Smart Food Sheds. So I see this as a potential area of collaboration between these two projects. So Laura, if you want to take it away, I think we're ready to go. And but you're muted.
Great.
And I'm going to turn off my camera.
Okay. Let me get, oh, 1 second. Sorry.
No problem.
How do I get out of presenter mode?
Yeah, I think there should be a switch, a screen that says switch screen.
This is why I work with esteemed computer scientists.
I think it's the one that has like the, what do you call it?
There we go.
There we go.
There you go.
There we go. Normal. All right. So NOURISH is really about we have a very large number of partners in government and the nonprofit sector. And what we're trying to do is build a platform that serves people, that addresses food insecurity as a geospatial problem by building an AI-enabled platform that accelerates the growth of small businesses in these communities that can sell fresh food. And I'm going to give you a little background on the justification and the science behind social science behind this, and then Amarnath will talk a little bit about the technological side of what we're up to. We've got a group, an interdisciplinary team, like all of the Convergence Accelerator projects. With we span everything from low to high tech. The low tech being very deep community engagement with community-based organizations and people in low-income communities, all the way up to artificial intelligence and agricultural AI as strategies to address this problem through a convergence science strategy. I just want to talk briefly about the national crisis. I know that ICICLE has a mix of people who work on the technology side, but there's also a lot of interest in agriculture and food systems in the Smart Food Sheds project. And so, you know, I've been working in this on the food system for a while, and part of what motivated me was working in low-income communities in San Francisco and seeing that the rise in childhood obesity-related diseases, we're talking about childhood diabetes and fatty liver disease, is just astronomically increasing. And this has been going on since about the late 1970s that we've been seeing this. The most observable trend is in obesity rates. And so many of us in public health are puzzling over what's going on here. What has changed? It can't be that we've all lost our self-control all of a sudden. There's something going on in the environment that is driving this massive change in health. And we don't worry so much necessarily about adiposity in the health field. We worry more about the diseases that travel with obesity. And they're the diseases that kill most of us: cardiometabolic disease, with heart disease and cancers being the leading causes of death. So what's important to observe is that a lot of this trend in rising obesity and related diseases coincides with a change in our food supply and the introduction of ultra-processed foods. These are, we don't even really want to talk about them as foods anymore. We talk about them as food-like substances. These are products using refined carbohydrates, fats, and proteins that are extruded in factories and then recombined with chemical additives. There's a lot of work. In fact, my team is working separately on the emulsifiers and other food additives that are being put into the food supply through ultra-processed foods. This is somewhat old data. At this point, we're up to about 2/3 of the US food supply. The calories in the American diet is coming from ultra-processed foods more than any other country. And notably, we have the highest rates of obesity and second highest rates of type 2 diabetes in the world. So a lot of the science is pointing us towards ultra-processed foods as being what may have changed to cause this rising crisis in obesity. A couple years ago, Kevin Hall at NIH did a landmark clinical trial where he put a bunch of people in a lab and he fed some people an ultra-processed diet and some people an unprocessed diet. And what he showed was that the calorie intake for folks on the ultra-processed diet was 500 calories per day more. That's the equivalent of a small Big Mac or a large fries at McDonald's per day. So this is a really big increase. And this is, again, pointing us towards ultra-processed foods as a potential driver of the obesity and cardiometabolic disease crisis in America. When you look at, well, what do we do about this problem? Should we be regulating this industry? And that's what a lot of my work is focused on. You know, we have this very concentrated industry with a few large multinational companies kind of controlling the food supply in an oligopoly. And so the question is, how do we address the rising obesity and cardiometabolic disease crisis in the context of a food supply that is dominated by a few companies. Now, when you drill down and look at obesity and metabolic disease rates in America, you very quickly see that there's a huge gap between the haves and the have-nots. And people who are living in low-income communities are much farther more likely to be experiencing obesity and chronic disease. And we find that the problem is geospatially distributed, so that we have segregated communities, the USDA, and some call them food deserts, some people call them food swamps, but they're places where basically the only thing available is ultra-processed foods. And this is causing a major problem from a public health standpoint in mortality rates as well as healthcare spending. If you look, across the nation, food deserts are strewn everywhere. They're in rural and urban communities. This is not just an urban problem, although the majority of food deserts are in urban areas. About a third of them are in rural areas. And with NOURISH, what we're trying to think about is a way to understand this problem as a geospatial and a problem of economic segregation of people. And that, in a way, it simplifies the problem, because about 2/3 of people with food insecurity live in a food desert. So we find that if we could address the people located in food deserts without choice, we could really make a dent in this problem. So currently, we've been working on an integrative model that is respectful of convergent science. We've got work all over the social sciences, as well as in agriculture and public health, to different ways of understanding this problem. At the macroeconomic level, we believe that the driver is really market failure in the food system. These numbers come from a Rockefeller Foundation report on the food system. And what you see is a case of massive societal market failure, where the costs to health and environment, the negative externalities of our food system, are actually exceeding the cost, the revenues that the food system brings to the economy. Now, we're working on an integrative model, and we're trying to understand what's going on in food deserts. Everyone in our society is getting heavier and experiencing higher rates of metabolic disease and a shorter lifespan. But we're seeing the problem intensified in low-income communities, many of which are food deserts. And so the question is, why are people in food deserts suffering so much more from this crisis than the rest of us? And we think that a lot of it, we start with low-income communities that become economically segregated through redlining and gentrification, well-known problems in the economy. SNAP subsidies subsidize the ultra-processed food industry, which drives market saturation in low-income communities, namely food deserts. Which weakens the supply chains. We've seen in a lot of our interviews that when the McDonald's and the big franchises move into the community, they price out the local grocery stores and fresh food outlets. This leads to blighting in the small business sector in the community, therefore driving further down the tax base and the economic viability in the community, and causing a sort of vicious cycle where poverty and food insecurity are deeply interconnected. The challenge here is that a lot of the current strategies for addressing food deserts, we believe, are actually contributing to the problem. So USDA, CDC, and so forth are trying, and many cities are through tax breaks, are trying to coax grocery stores back into these communities, convenience stores getting dollar stores to sell fresh food. And we believe that these problems are really contributing to further market saturation by large outlets in these communities, therefore contributing to this problem of economic blighting combined with food insecurity. So at NOURISH, we're trying to evolve a radically different solution to this problem. And it really comes down to building out the small business sector in these communities in a way that can drive economic development, keep a non-extractive economic model that can keep wealth circulating in the community, and allow for entrepreneurial talent within these communities to be supported in developing solutions that really work for people in the communities. So the beauty of small businesses is that they can be, you can put them anywhere. So if you're in an urban area, you can put a food truck next to the subway station. If you're in a rural area, you can put a farm stand out on the street. And so there are many, many ways that small businesses can be evolved to, if they can be empowered and supported to sell fresh food, this is a much better strategy, we believe, than, again, subsidizing large food franchisors to come into these communities. Small businesses are one of the really high value prospects here is that these are efficient job creators. We know that small businesses compared to large businesses are really bring a lot of value to the local community, bring more profits. So they're going to likely elevate the tax base, support jobs, and hopefully transition these communities away from the vicious cycle. So, so far we've been working on this problem for about a year. We've conducted over 300 interviews, use-inspired interviews to develop the platform, built partnerships with the Small Business Administration and these two critical organizations, SCORE and SBDC, that provide business mentoring services. They're located all around the country and allow us to work with people who actually work with small business entrepreneurs in low-income communities to build the NOURISH platform as a way to support end users. So we're building the platform for business mentors to work with, and also independently small business entrepreneurs who sell prepared foods, and as well as small farmers. And our research has really showed that there are numerous challenges that make it hard for small businesses to compete with the fast food franchises and convenience stores in their communities. And so we're building the platform to really address the challenges that these small business entrepreneurs face. This is our team. We've got 4 different co-PIs and a wide range of partners, including ICICLE. As well as small business funders, so people who are micro lenders and venture funds that are impact investing in these communities, as well as these organizations that support small business development in low-income communities. The platform has 4 main features. It has a business financing piece, which provides customized packages for financing small businesses. There are small business administration loans, USDA farm loans, but then there are also private sector loans and grants that are actually very hard for entrepreneurs to locate and apply for. One of the features is a geospatial, highly granular market opportunities map. So this allows the entrepreneur to figure out, well, if I want to open up a food truck, should I put it on this street or that street? Where's the best foot traffic? Where are the open storefronts in my community? We have a business regulatory navigator that helps people navigate the business permitting process in their local government. And then we have, this is the piece that Matt is really working on closely, is a supply chain partner finder that connects small farms and prepared food businesses in the same community. And this is where we're hoping the ICICLE fresh food, smart food sheds platform can help us to build out this piece of the platform. And we're hoping to become a use case for ICICLE in this way. Currently, our test sites are in San Diego and Imperial counties. We're working very closely with business mentoring organizations that work with the Small Business Administration there. We're also working with independent nonprofits and local community development corporations. And these are really grassroots organizations that work with immigrant communities and low-income folks who want to become entrepreneurs. And they are really very integral to the work that we're doing. They're really helping us co-design the platform. We launched in at the beginning of this year, so we're just ending the first quarter. We have been doing quite a bit of partnership development, sustainability planning, as well as building up the platform in ways that Amarnath is going to share in a minute. And so I think I'll leave it here. What we have in NOURISH is really a very different solution to food, the nutrition security crisis. The goal is to create a ground-up, community-driven solution to this problem that leverages the often, just the very name food deserts evokes a sort of deprivation model. But in fact, what we find is that these communities are really have many, many assets and resources that are untapped in solving this problem. And we think that through small business development, we're really looking at a solution that can move quickly and drive change in the nation's food security crisis. So I'll leave it at that and let Amarnath take over.
While I set up, if you have questions for Laura, please go ahead.
Yeah, that's great. We can wait for you to get set up there, Amarnath. Laura, I'm wondering if you can tell a little bit about the experience you've had in bringing together this community from your perspective, what it's been like to assemble domain experts plus technology experts in this convergence accelerator.
Well, I've spent my career doing NIH-funded research. What's really interesting to me about the Convergence Accelerator is, as a federal funding agency, NSF in general, the NIH is incredibly conservative. And I've sat on study sections for many years and watched grant review happen and been on, various expert panels for NIH. And the system is a very conservative funder. And the Convergence Accelerator, and so far my experience with NSF is radically different. This is a very, what we would call in NIH speak, a sort of high risk, high yield project. If we really make this work, and if our theory of change is correct, we're going to have a massively transformative effect on communities. And so I would say that assembling the team has been, I am very lucky because I'm at the University of California and I've worked with the Global Food Initiative, which is a UC presidential initiative. I'm on the board of the GFI. And it already was bringing together a lot of interdisciplinary scientists. So I knew folks at the San Diego Supercomputer Center. I had been working with Paul, our community engagement expert, for about 10 years. So once we figured out that this was a potentially fruitful proposal, it was really quite exciting to be able to tap all the talent around me to build this multidisciplinary team.
Great, thanks. And I see Michelle Miller, who's one of our domain experts in food system from the University of Wisconsin. I don't think she's purposefully evoking the petroleum industry there with her Zoom. With their Zoom.
I was wondering about that.
Michelle, please, what's your question?
Yeah, so Laura, wonderful presentation. Really exciting work with Nourish. I've been working a lot in food access in rural areas and looking at, we did a recent study in low-income areas in northern Wisconsin and found that there was a kind of an anti-competitive environment in the wholesale sector, and that was kind of the main thing depressing any kind of local effort to build businesses to address this need for more access to higher quality nutritional food. Have you looked at that at all, or is that part of your?
Sounds like a fascinating case study. Have you written that up?
It's I'm in the process of writing it up.
I would love to see that, and I'd be happy to read it over before you submit it and give comment. We hear a lot of really interesting stories in our end user interviews and working with the community-based organizations about what's going on in these economies. We've also got I've heard very interesting stories about how the big food franchisors push out small businesses. So it doesn't surprise me at all. And I think a lot of it comes down to the supply chain work that Matt is leading up. If you can control the supply chains for fresh food, you really you can put these local businesses out of sale and drive up out of business, drive up costs, so drive up the price of fresh food. So we're very lucky to have Hans Taparia, who is an expert he's a business professor at the Stern Business School at NYU. He's one of our co-PIs, and his area of expertise is small business development. And so we're really working hard to push the levers for economic development and growth in businesses. And that's driving a lot of how we're setting up this platform, thinking about competition. But it seems very locally, the stories seem very, they're local case study type stories that I hear. I'm not hearing a sort of, each community seems to have a different story to tell around how its economy is being disrupted by these franchises. So that's why I'm interested in your case study.
Cool. Well, thanks. I will definitely send it to you.
Great.
That's great. We've got time for one more quick question before we jump into Amarnath. Alfonso, if you can make it.
I was going to say, no, rather not. Let's just go right to Amarnath. I think that's cool.
You sure?
And I guess, Laura, the thing that Michelle, I think you'll find it common. It's simply not investigated. There's a long social science history behind collusion. And
yes, absolutely. Collusion.
Yes. Institutional arrangements that so I've written I have 2 books, I guess, on small business in
really
communities of color. Yeah. So anyways, there you go. Forward.
That's fantastic. Yet another touch point for potential collaboration.
I have
resource
a couple
across.
Of books to look up.
Yeah, great. All right. Next up, we have Amarnath Gupta from San Diego Supercomputer Facility, who's going to walk us through
Supercomputer Center.
San Diego Center. I said facility, didn't I? I meant center.
Okay.
SDSC. Yes. Take it away, Amarnath.
Okay. I normally say UCSD because SDSC is a part of UCSD. They are not 2 different institutions. All right. So when I asked Matt, what should I talk about? Matt said, well, be technical. That's kind of strange because technical how. So here is something Matt said I should talk about, and that's the National Data Platform. So I'll start with that. Last year, we got a multi-institution project from the National Science Foundation called the National Data Platform, and it's a pilot project. The goal is to figure out whether there can be a strategy where different researchers from different disciplines, and especially people who are interested in large problems like climate scientists, would be able to come to a common data place and do everything that they do with their data. They should be able to put up their data there. They should be able to share data. They should be able to analyze data. They should be able to run AI models on data. And such a platform currently doesn't quite exist. So one of the hopes of the National Data Platform is that it will be efficient, and it will be used by the NAIR, which is the National AI Research Resource Institute. So one of the primary takeaways here is when we build NOURISH, how do we scale it and how do we make it available to other researchers who do other things with it? Because we are collecting data, and that data might as well be used for other research. So what you should see here is that up in this corner, top right corner, NOURISH is a use case for the National Data Platform, because we wanted to say that knowledge graphs are very common. NOURISH is not the only group, obviously, producing knowledge graphs. Many different groups in many different areas are producing knowledge graphs. If you do have large-scale knowledge graphs, can you serve them? Can you construct them? Can you operate on them? The platform essentially is going to enable, the goal is to enable all of this. Can I construct knowledge graphs sitting on NDP? Can I take somebody else's knowledge graph and build my own on top of it? Can I have my own services that we would do on the knowledge graph? So what we want to utilize the NDP for is this kind of making whatever we produce in NOURISH more scalable and more accessible to the research community and possibly the applications community as well. One of the hallmarks of this particular project is this piece called OSDF. Now, the OSDF is essentially a strategy which says, if you have data on the data that's located physically on the West Coast, and if you're trying to do some operation and you are sitting on the East Coast, there is a delay. And we have all seen this. Anybody who deals with a lot of data that's distributed over the country, we see these delays, and sometimes processes suffer because I'm still waiting for the data to come through the wire, and the network is giving me problems. We have all seen this. So the solution for the OSDF is, can we create local caches of data? So OSDF will have a distributed system of data caches. And whenever there is a request for data, it will go to the nearest cache and get it from the cache. Now, what kind of data would go into the cache? The way OSDF was originally designed is just any bag of bytes. But what we are saying in the NDP project, but that is not necessarily that. Is you run a model and the output of the model is data. You create a knowledge graph and you do queries and you create a mini knowledge graph that you want to do further things on, then the output of that query is data. So this data needs to be cached, because if somebody in Australia is trying to use it, we better make it available. So this is the framework in which we are trying to do our NOURISH project so that we can scale up. I'll now move to the NOURISH platform, and I'll keep referring to the NDP regarding where the touch points are. Matthew, I have a lot of slides, so you have to stop me when the time is up.
No problem.
All right. So the NOURISH platform architecture sort of looks like this.
You've got 15 minutes, by the way. We'll save 5 for questions.
Okay, whatever. You will stop me. You are my gatekeeper. All right. I am a database guy. So that's what I understand. So the design of the NOURISH platform has been from the viewpoint of somebody who has been doing data integration for years. Now, in this platform, there are really 3 pieces. One is this knowledge graph that we construct is not really in one place. It's not a huge RDF structure. So you create the RDF structure and you query it. That's not what I want to build. Why? Because data will come incrementally. We are building this now, and when the food supply chain information comes from ICICLE, I want to be able to integrate it. So the way we view this problem is that the knowledge graph that we have is defined virtually. That means I have the knowledge graph, but the actual storage of the data may be in a graph database or maybe in an RDF database, but it would also be in a relational store. It will also be in quadrant or some other vector store. So it will be distributed across data models. And when our job is to A, construct that virtual knowledge graph from the sources from which it comes. And we must have the ability to query it through the interface. So this is the first piece. The second piece is the proactive conversational recommendation. I'm sure this group knows what conversational recommendation is. Proactive, if not, tell me. So we are interacting with the system.
Yeah, we've got a group working on that, so you can feel free to move quickly. Okay,
fine. The third piece is lifelong learning. So this is the disconnect, Matthew. So I didn't exactly know what people do or do not have familiarity with. Lifelong learning essentially says our data is going to evolve. And as we talk to people, we are going to gather more and more community knowledge. And this should somehow be ingrained into back in the knowledge base dynamically. So this has been called lifelong learning, and all our methods should somehow support it. So currently, we are working on the first piece, and we have just started designing the architecture for the other 2. So we'll talk primarily about the first piece. So just to make sure that we understand the scope of knowledge here, we are still gathering data from sources like the USDA, also Google API, also survey data that's available to us through ArcGIS. All the regulations, Laura mentioned the regulation navigator, all the regulations that exist, all the funding programs that exist that people can use. So as you can see, this is a very diverse collection of information that somehow would feed the knowledge graph. So how would it feed the knowledge graph? My definition of knowledge graph is really, it's a property graph. That means no, it's not RDF. Nodes and edges have attributes. And this is a classic property graph definition, except that every node must represent an entity. Now, how would I get the entities? There are multiple ways. One is I have an existing ontology. If I have an existing ontology, and this is food on, everybody here knows food on. If I have an existing ontology, I must modify my knowledge graph definition so that it's ontologically grounded, which means every node in the knowledge graph must have a path to the ontology. If it is fully grounded, then every single node has it. If it's partially grounded, that means only a subset has it. And our intention would be to see if we can have ontologies so that the fraction of nodes that are not ontologically connected is minimized. This is one place where we connect with Matt, because he knows all about the different ontologies which could be used in this process. And again, it's an incremental process. We would not know what all the ontologies are on day one. Okay. The next thing is called contextual segmentation. Where does the data come from? A large part of the data comes from documents. One class of documents that I choose here are all the city regulations. So we have collected the regulations of all 18 cities and the San Diego County, all 18 cities in San Diego County, the San Diego County itself, and laws of California that we think are relevant. Now, if you look at any single section of a municipal code, it looks like this. So what you would see here is that one section references other things. Those other things could be other sections within the same document, or the other sections could be documents which is created by another jurisdiction, for example, the state. So every city has pointers to, here we conform to what California says. Therefore, the knowledge graph is going to have a superstructure of these subsections. And therefore, my knowledge graph is fragmented. So it's their knowledge graph, because the word establishment is defined in two different ways between Chula Vista and San Diego, for example. So therefore, we need to partition the knowledge graph within its scope. All right. Given that that's what we want to construct.
10-minute warning.
Fine. I'll stop whenever the time is up, but I have to go through this. We said the knowledge graph is virtual, but how does that really work? And how do we maintain quality? We have determined that whenever we construct the knowledge graph, there are certain precautions we need to take. One precaution is that because we are gathering up this knowledge from multiple data sources, they were not really created by one person, so it's not necessarily consistent. But when it becomes a knowledge graph, it better be consistent. Otherwise, it will be low quality. So we are trying to generate a knowledge graph that at least takes care of these 4 types of quality issues that can occur. Our way of doing it is by a set of theories that have come up, in database systems, and I'm not going to deal with this, stay on this for a long time. There are constraints which say, if you see this in the source, you should see that in the target. And these 2 formalisms of what I should see in the target knowledge graph, if I see blah in one or more sources, is part of what is driving the knowledge graph definition process. So our premise is, for every data source that comes through, regardless of what type of source it is, it could be MongoDB, or it could be Postgres, or it could be Neo4j. If I have a schema, then I should be able to define patterns on that, in that schema of the local source. And I should be able to infer, and this is where the reasoning comes, infer the patterns on the target being the knowledge graph. Okay, this is just theory of what it can express and not express. So our strategy is you start with the native schema of what comes in, you define the constraints, convert it to a graph model, and convert the relational constraints to graph constraints. And then you, doesn't matter whether it comes from a relational source or a cipher source, you do the same thing. Now that you have a collection of graph constraints, you will figure out what the nodes and the edges of the target graph is based on the constraints given to you. This is the process we are trying to automate right now. And we have done it partially. And this is where the focus is. By the way, you also can put constraints on the graph itself. You can say things like, there should be no isolated node in my target knowledge graph. Okay, I will skip this, but I want to say one more thing about where the LLM or any other NLP technologies play a role. When you take an input schema and when you construct the knowledge graph from it, you need to do something that takes the schema and semantically characterizes this. So if I have this schema on the left, before I go and integrate and produce my graph generating dependencies and so forth, I need to infer that the semantic type of this whole thing is really a business industry. It is not something else. Similarly, when I have categories, it would translate to business categories. So right now, we are in the process of defining the logic by which such semantic inferences can be made. We have seen that if we do it through LLM, it does a good job 75% of the time. And the other 25% time, it really does something bad. We need to fix that. We are fixing that. The other thing one can do, the second thing one can do is called schema matching, which says if I have two different tables or a graph and a table from two different data sources, can I figure out how they correspond? And I should be able to say that table, that column, which is called target, really should say sales channel or distribution channel. That gives me fresh vocabulary that I can potentially use when we are going to do a natural language query against this source. The third piece, where LLMs or any other NLP technology, we are looking at it right now, is when you have two sources and you ask how do they correspond, it would essentially say these two tables are called differently. One is just a bunch of integers. The other is an array of strings. However, they are semantically the same thing. This has been called schema mapping in the data integration literature. So what we are trying to do is to figure out how much of the mappings that we will construct, all these GGDs and GEDs, automatically. But you still need to have eventually a human being who will say, okay, this is right, because we know that no matter what we do, it will not be completely right. So if there's a knowledge engineer doing this, the system should cook it to the point possible, but it should be eventually it should be validated and approved by a knowledge engineer. How about the unstructured part? Well, if I get a piece of text, we are creating the graph by first converting it into an internal semantic structure, attaching that semantic structure to an ontological chain, in this case with BFO, and then we are generating the edges. So this is happening now. We are also figuring out that there is no one single strategy for generating the edges. In fact, we found that there are 19 possible ways in which we could infer semantic relationships if my data is text-like. One particular type that we find a lot in legal documents is definitions. So it will typically say something like the yellow and blue. Such and such term means, and there will be a definition, and there will be other terms which will use that definition to define the further thing. What we are saying is, can we automatically convert this into OWL, an ontological description? We are currently not using the full power of OWL. We are just using the plain ALC, the inverses, and cardinality constraints. So people would say things like, you can receive a penalty if you do not return something in 3 months. This in 3 months becomes a cardinality constraint. and this should be expressed. So if I restrict myself to a very small subset of what OWL can express, then our experience so far has been that we are faithfully generating them. The problem comes when you have done this with all different definitions and you're trying to string them together, you will see that there are missing nodes, missing concepts that connect them. This is what we are trying to work with now so that we can get a more complete and consistent knowledge graph.
Amarnath, this is fantastic. I do want to leave a little bit of time for questions. So
I can stop right after this slide if it's okay with you.
Yeah, perfect.
So this is the part that we have just started working on. We have just hired a postdoc, and we have hired one of our own students who was trained in our group. This is the query processing pipeline, where we are beginning to take a human question, and then we go through this entire pipeline. This is not completely developed. I can stop here if you want, or I can do just one more slide to show you something. Let me do one more slide. Okay. One of the questions is, what is the principle behind the conversational analysis? Because we are trying to do a conversation, but we are also trying to recommend. We are currently inclined to use a class of game theory that's called positive sum cooperative games, which has not the Nash equilibrium, but a comparable thing called the Nash bargaining solution. And there are alternatives. Nash's solution is not the only solution. This is what we are looking at as the theoretical piece that would drive our conversation to see whether the conversation is going positively and ending in something real, or is it just chit-chat? I'll stop here.
Thanks, Amarnath. That was really, really great overview. And I know we're trying to cram a lot into a little bit of time. So really, really appreciate that. Want to open it up for questions from folks at ICICLE. There's a whole lot there to digest. Amarnath, what stage would you say you're at right now relative to development? Yeah.
Our first year deliverable is the knowledge graph. And we know that the knowledge graph will, the knowledge for the knowledge graph will keep coming. So what we are doing right now is to take whatever data we currently have and creating the methodology so that we can convert it into a virtual knowledge graph. We are to test that the knowledge graph actually works. We are building a very small piece of the query engine that would go query the knowledge graph. We have a site visit next week. We are hoping to show a part of it at that visit. But what we need to complete in year one is the whole knowledge graph construction process. That's where we are right
now. When you're saying that, you're saying that for NOURISH, or you're saying that for?
No, I'm saying it for NOURISH. The way okay, if you break down the work, like, can I do schema inferencing? But that can become a service that will go land on NDP. So if you take bits and pieces of the NOURISH project, which could be services that are generalizable, they will go up on NDP. The knowledge graph, as we build them, they would go on NDP so that people can query them. But we will be, again, incremental about it so that we can actually do it practically.
Great.
So many of the little procedures will become NDP services, and the data products like the knowledge graph will also be resident in NDP, but NDP is not really about NOURISH. We are using it to make it scalable and available to the rest of the community. Okay, I see one question.
Yeah, Joe, great.
Yeah, hi. Well, first, just thanks both. Thanks to both of you, both of the speakers. It was really great talks. I guess hard to know exactly what to say since we only have a minute left here, but I guess I want to say broadly, we in ICICLE are developing our own, we are developing a knowledge graph infrastructure. And so I just want to make sure you know that, and to make sure that we collaborate, if at all possible, because I see a lot of potential connections. I guess if I could ask just one question, it would broadly be kind of like, what is the public API, if there's a way you can describe it, for consuming NDP, or for instance, I have a knowledge graph infrastructure. How do I, at a very high level, what is the API for integrating with NDP, my knowledge graph infrastructure?
Okay. Ask me, 2 months from now.
Okay, yeah, no problem, no problem. This can be an ongoing discussion, but
because that is exactly what we intend to do. Now, we are not the only knowledge graph builders. We are not the only knowledge graph infrastructure. We are doing it for our purpose. But there are 1,000 other people who are developing these OKMs, right? So they should be able to take their thing and make them available and so forth through NDP. What is the right API they should call, and what's the mechanism? We're working on it, because there are issues about, okay, is all of your knowledge graph public, or are parts of it private? Do you want to, when a query comes to you, who does the query? Does it get served by your infrastructure or by NDP's infrastructure? There's a lot of questions in the middle that we need to sort of get an answer for before we can proceed.
Yeah.
But I will remember this question. I will come back to you when I have an answer.
Sounds good.
Joe, just so you know, like, part of the reason for this meeting is because we definitely see, collaborative potential here across our use cases.
Yeah, a lot of collaborative potential, a lot of overlap, and also a lot of potential, divide and conquer strategies we can do here.
That's what I'm hopeful for.
So if we want to know more about the knowledge graph infrastructure that you are building, should I talk to Joe?
Yeah, you can talk to me. You can, so
because here is the question, right? At some point, when we are ready, we'll say, okay, now let's try it. Now let's try to connect your infrastructure with NDP.
Right.
And we need somebody with, like, a hands-on person who will work with us through this process.
Yeah, you can speak to me, and I can field it to people on my team, or
I need one contact person, somebody.
Put me down.
It'll possibly not be me. It'll be possibly somebody from my team that, and we'll have to make that happen.
Yeah. We need to get the worker bees talking to each other.
Yeah, that sounds good. Again, thank you very much.
Sure.
Looks like we're a few minutes over. Any last questions from folks for either Laura or Amarnath before we part ways?
I have a question to all of you. I keep hearing about the knowledge graph infrastructure, but I know nothing about it. What about a seminar when you present your knowledge graph infrastructure and we are listeners?
Sounds great.
I think that would be a great idea. Yeah.
Good thumbs up from Patrick there.
This is the first of many conversations, because there's so many touch points, and we.
Yeah. So that's what I'm trying to understand. I'm trying to understand where the touch points are, then what we can do about it.
Yeah. Well, this is the beginning. This is the toe in the water from your perspective coming to us, and I guess we'll come back. I'm putting my ICICLE hat on now and saying ICICLE will come back to NOURISH and NDP. But I think this is the.
Yeah.
I'm talking to myself.
The two sides of your brain.
Yeah, talking to myself. Yeah, okay. All the rest of you can go. I'm fine over here by myself. No, terrific. Thank you both very much. I think it's been great. It's been informative. at the domain level and at the technical level, and to that point, I think this is just the first of many conversations. I'm looking forward to a lot more.
Laura, thank you very much.
Thanks,
Thank
everybody.
you both.
Yes.
Great
Yes.
meeting you all.
Bye. Bye.
Right.
Bye.
Thanks. Okay. Bye.